two streams. One is the hydrolyzed urine, neutral recurrent from hydrolyzed urine. One is investigate the impact on the sewage treatment system using the urine diverter sewage. So basically what you see here is the sequencing batch reactor activator sludge. It's a very conventional process.
Right.
Yeah. So for this one, we feed them with the sewage. This sewage is the 25% urine diverted. Yeah.
Oh,
So
25%.
yeah, so we are trying to mix the brown water, urine, and grey water, and adjust the portion of urine so that we can create the 25%, 50, 70, and 100% urine diverted sewage.
Okay.
Yeah. So what we're trying to observe is we mainly focus on two things. One is the treatment performance, of course. The second thing is how we can increase the treatment capacity of this one. Because when we reduce the urine, we can reduce the nitrogen. So obviously it can increase the treatment capacity of this sewage. But we want to quantify to what extent it can increase. Yeah. So this is basically the urine diverted sewage. Yeah.
So this is more about downstream effect.
Yeah, true.
Right.
Yeah.
So where do you get this gray water? Is it real gray water or
let me
is
show you
it?
the
He has a recipe.
I
for
think
everything.
smell is from here.
It makes gray, it makes black.
So this is the brown water. This is the feces, synthetic feces. Yeah, synthetic feces. So I just need to mix this with 24% of water, so it becomes the brown water. Yeah.
So you wait,
So
put it in. Yeah.
So this is the synthetic urine. Yeah.
Oh, there is a fridge next door. Yeah.
Yeah. Then the grey water, basically, I just use the chemical. I mix it. Yeah, and then I dilute with water.
What's
then, very long recipe. Basically, sodium acetate, glycerol, starch, sodium bicarbonate, and cellulose. Yeah. Yeah.
Yeah. And the yellow water?
Yellow water, this one. It's
Why?
not yellow,
It's not
but
yellow. Oh, we got a major problem.
I should just
This,
some dye.
this
Synthetic
is
urine.
this synthetic yellow.
Yeah,
right,
synthetic
okay.
urine.
So
Yeah.
1%. So for
Yeah.
1 liter, 10 milliliter this.
Yeah, yeah. Then 24% of brown water
So-
and 75% of grey water.
And you can see
Yes.
it degrades very fast. So we have issue if you start the experiment in the morning. This is already degraded, but then in the morning you change the feed, and then you can run a few batches to record the data. But yeah, there's some degradation obviously because bacteria grow back into there.
Yeah.
So how would, because actual feces is a lot of coliform and those sort of things, so you don't have it in this one.
Yeah, no.
No,
Obviously,
no,
no.
yeah.
Yeah, no.
There's solids, but no bacteria.
Yeah, yeah.
So your lab has possible to use the real wastewater or real?
Yes.
It's okay,
This
right?
was a sludge lab
It's
before we
okay.
arrived.
I
So
see.
they were using sludge from wastewater treatment plant as the main experiment here.
I
So then we came, we bring sewage. So this is not real, but Angel uses real, and this is real urine. So we got everything real in here.
I see. Okay.
Yeah.
So what's the measurement you are trying to do? Okay, so you have a more urine diversion. So you want to try to use a sequence batch reactor. So how much aeration you can reduce, or how you want to see your parameter to have a downstream effect?
Well, so in order to be more consistent,
Yeah.
so in all scenarios, we're
Yeah.
trying to maintain the total nitrogen of 10 milligram.
Yeah.
So how we can maintain it is we increase the decanting ratio. So the baseline without urine diversion is 20%. So for 25%, we increase to 0.25, and then we increase, so that the Tn of the effluent remain the same. So we determine how long you need to use to reduce the NO2 and NO3 to below 1 milligram per liter. Of course, ammonia no problem. It's always below 0.1. Yeah. So then we can see what is the shortest possible HRT we can determine.
I see.
Yeah.
Okay.
So yeah, the more urine you take out,
Yeah.
then a few things happen. You can decant more because you have less nitrogen coming in. So if your nitrogen targets 10 milligram per liter, then in the base case you decant this much.
Yeah.
Then you start decant this much and then this much. At 75% urine aversion, you decant almost all, and then you add all new wastewater because that wastewater has much less nitrogen, and you're still loading the same amount of nitrogen. But then there's more COD, so you have to also lengthen the aerobic phase to facilitate COD removal. But you have more swap over, so you get more wastewater treated
Yeah.
over one day than in the best case scenario to the same standard.
Yeah.
But we have seen a problem which you might
Yeah.
discuss after lunch. As soon as you start to remove a little bit of urine and make those changes, nitrite starts creeping up. We've seen nitrite creeping up.
So nitrate creeping up when?
Even at the end of the cycle, yeah, it cannot reduce.
So
to
after you
one.
remove divert some urine
Mm-hmm.
and change the batch cycles accordingly, the ammonia is well removed, but nitrite is becoming very hard. It goes down very slowly, and so we're now like trying to work out what type of reason might be causing that. You can show the data.
Yeah,
after that.
later after lunch.
So let's head to lunch so we can.
Okay, let's sure.
Then I have to go teaching, so